No tutorial is assigned for this course. So comparatively, this is easier subject. The total internal assessment marks for this course result is 30. Like other theory courses, allotted marks, and the university exam covers 70 marks. If you successfully complete this course, you can acquire 3 credits. As you all know, every course is having few objectives. So before going into this course, we need to see these objectives and try to cover the course which give you these objectives, and in order to test whether these objectives have brought into you or not, so we need to check these outcomes. So objective can be seen before starting of course, and we need to evaluate ourselves with the help of these outcomes. So the objectives written for this course are: the objective of this course are to impart knowledge of, okay, there's some mistake in this, to be able to understand different types of transducer, their characteristics and applications. The other objective kept is to learn and understand the standards of calibration of measuring devices. So we keep these two as the objectives before starting the course. In this course, what we will do is we'll try to learn different types of transducers and see their characteristics and their applications. And also we will see how to test what are the standard setups available for these transducers. Transducer other name is nothing but measuring devices. So the other outcome, objective of this course written as learn and understand standards of calibration of measuring devices, or learn and understand the standards of calibration of different transducers. At the end of this course, student will be able to describe various static and dynamic characteristics of measuring system. This outcome we can acquire from Unit 1. And at the end of Unit 2, student will be able to acquire this knowledge. They will be able to classify different transducers. And at the end of Unit 3, student will be able to use inductive transducers, capacitive transducers for various sensing applications. And at the end of Unit 4, student will be able to discuss temperature, actually not pressure, temperature standards for calibration. And at the end of Unit 5, student will be able to use pressure transducer for various sensing applications. And at the end of Unit 4, student will be able to use temperature transducer for various sensing applications. Maybe a little confusion. Usually the outcomes are written in this way. First outcome is written based upon Unit 1. Second is based upon Unit 2. Third is based upon Unit 3. Fourth is based upon Unit 4. And fifth is based upon Unit 5. Hope you understand up to now. Please acknowledge with few voices.
Yes, sir.
Yes, sir.
Yeah. So this is about objectives and outcomes. Let me give you an information. Objectives are the motivation, and outcomes are the mechanism for testing ourselves. And outcomes can be seen after the completion of the course. Okay. Let us see each unit in detail. Okay. So in order to make you to understand the content of each unit in detail, take the help of this whiteboard. Okay. In Unit 1, what we need to do is, as usual, we need to see the introduction to the course. As I already told you, Transducer can also be called as measurement system. It can also be called as measurement system. So, introduction to transducer means introduction to measurement system. The system under discussion is measurement system, right? Which we are going to learn in this course. Under introduction, what we will do is, as usual, you see in all the courses, the introductory discussion about that course is nothing but discussion on characteristics. Is it clear or not? My words are
Yes,
okay
sir.
or not?
Yes, sir.
Huh. What do you mean by characteristics? Characteristics are nothing but the features. The features of the system are called as characteristics. Characteristics. Usually, we all know that characteristics can be calculated by giving some input and by measuring the corresponding output. Agree? Yes, no?
Yes, sir.
Yeah. Usually, characteristics is a function of excitation and response. So, if I write the equation for characteristics, it can be something like this. It's a function of input, which is nothing but excitation, and output, which is nothing but response. The other name of input is nothing but excitation. And how about response? Output?
Output.
The other name of
Response.
output is nothing but response. So characteristics is a function of excitation and response or input and its corresponding output. Is it clear?
Yes, sir.
Yes, sir.
Yeah. In our course, we divide, or usually characteristics are classified into two types. Types of characteristics. First one is static, and the second one is dynamic. Okay. We are all familiar with the word static. Static means remain constant. But what remain constant? The parameter value with respect to time. Parameter value
With respect to time.
time is constant. Right? So static
sir.
characteristics are nothing but the parameter whose values with respect to time is always constant. Hope it is clear to everybody.
Yes, sir.
Yes, sir.
Now, the reverse is dynamic characteristics. Its values varies with time. Varies with time. If time changes, the value also get changes. So this is about a brief about types of characteristics. In unit 1, what we will do is we try to study different types of static characteristics parameter and different types of dynamic characteristics parameter. Just see this. Linearity is one of the static characteristic parameter. Hysteresis, threshold, reliability, repeatability, maintainability, span, and calibration. So these parameters are nothing but static characteristics parameter. Whereas dynamic characteristics parameter, actually we are not directly going into dynamic characteristics parameter, But before that, what we are trying to do is, we are trying to study first order system, second order, zero order system, first order, zero order dynamic characteristics model, first order dynamic characteristics model, and their responses to impulse, step, ramp, and sinusoidal input for frequency responses. So let me make this thing more clear with the help of the whiteboard. Hope you understand the difference between static and dynamic characteristics. Let us see.
Yes, sir.
Let us see. The parameters of static characteristics. या फिर static characteristics parameter. Static characteristics of, we can call transducer or measurement system, right? Both are same and one. First, we will study as linearity. Linearity of measurement system. Second one, I just copy from there. Sorry. There are many more, but we are learning only this many. I think it's difficult to do. Yeah. So on your screen, the static characteristics of measurement system is there. The second one is hysteresis. The third one is threshold. The fourth one is repeatability. The fifth one is reliability and maintainability. The next one is span, and the last one is calibration. A few more also we will see during the course, which are important. Okay. Hope it is clear to everybody.
Yes, sir.
What is linearity? What is hysteresis? What is threshold? We will discuss. About dynamic characteristics. So it is not asked directly to go and discuss dynamic characteristics parameter, because you will learn dynamic characteristics of system later also. Instead, what it is asked is to first see the zero order model of dynamic characteristic model of measurement system. It is asked to first cover modeling of measurement system. Under that, the first thing we need to cover is zero order model. Second one, first order model. Okay, first order model. After seeing the modeling of measurement system, it is asked to see the testing of first order model. with three different types of excitations. First one, step input. Second one, ramp input. Third one, impulse input. Okay. After seeing the modeling of a measurement system as first order, zero order, and first order, it is asked to see the testing of first order model with these three excitation in time domain. Maybe something are looking little maybe to you. Don't worry, we are going to discuss these things in detail later. Okay. The second thing under dynamic characteristics is nothing but testing of zero order model. Testing is not necessary. Only from first order onwards testing is necessary. So first order model of test for measurement system testing we will do with three excitation. Remember in bracket I have written something. Are you able to read that? In time domain. Do you understand the difference between time domain and frequency domain? Yes, no?
No, sir.
No problem.
No, sir.
No problem. No problem. No problem. So what I will do is, this I will cover in next slide. This I will cover in next slide. But as I am giving you the structure of course, so please take it. Okay. Here in this slide, take the information as testing of first order model with this three excitation. This testing is done in time domain. No problem. We'll discuss about time domain in next slide. Maybe after completion of okay. Unit 1. Then after doing testing operation with these three input in time domain, we try to do testing operation testing of first order system with, but this is in frequency domain, okay, with sine input, So this is about the structure of unit 1. Can I take you once more from the starting?
Yes, sir.
Yes, sir.
Yeah. Unit 1 course content is as follows. First, what we will do is, in unit 1, we try to see introduction to this unit, this course. This course name is actually Transducer Engineering. The word transducer can also be called as, or the synonym of transducer is nothing but measurement system. Short form is MS, measurement system, right? So in under introduction, what we will do is we see the characteristics of this particular system, which is nothing but measurement system. So the classification of characteristics of measurement system is as follows. First one is static, second one dynamic. Okay. Before going into static and dynamic characteristics discussion, I have shown something over here. If suppose the measurement system is represented by this block, the meaning of characteristic is nothing but extraction of features, okay, or the performance parameter. The performance parameter of any system can be calculated by giving some output and measuring the corresponding output. By giving some input and measuring the corresponding output, right? That is the reason I have written over here the function which give characteristics is a set of input comma output or excitation comma response. Hope it is clear to everybody.
Yes,
Yes,
sir.
sir.
Yeah. After that, I have taken you into the types of characteristics. The characteristics can be categorized into two types. One is static, another one dynamic. The meaning of static characteristics is, just now I told you what is the meaning of characteristics. Uh, Measuring the response of a system by giving some output is called as characteristics. So if the parameter under measurement remain constant with time, then it is called as static characteristics. If the parameter under measurement varies with time, then it is called as dynamic characteristics. Hope it is clear to everybody.
Yes,
Yes,
sir.
no. Yes, no.
Yes,
Yes,
sir.
sir.
Yeah. Thank you for that. The static characteristics are here listed. First one is linearity.
Yes, sir.
Second one hysteresis. Third, threshold, repeatability, reliability, maintainability, span, and calibration. There are few more, but we are restricting ourselves to this plus a few more that also will write over here. Additionally, we need to study this many. First one, additional static characteristics. Accuracy and precision. Accuracy and precision. Then types of errors and its types, then range, then resolution. Okay, so these many additional parameters also we'll try to cover in our course, apart from the parameter mentioned in the syllabus. Hope it is clear to everybody.
Yes,
Yes,
sir.
sir.
Yes, sir.
Now, under dynamic characteristics, the discussion is little different. We cannot directly go and discuss dynamic characteristics parameter. Instead, what we will do is, we do discussion of dynamic characteristics in this way. First, we will try to see modeling of measurement system. Zero order model, we will try to see how to make zero order model. I will show you with the help of mathematical equation. Linear differential equation with constant coefficient. I will show you that. And then we will see how to make first order model of measurement system, and also we will see how to make higher order model of measurement system. That is the first thing under this topic. Then, after seeing the preparation of the model of measurement system, we'll try to see how to perform testing of this model, okay, in two domain. One is time domain, second one frequency domain. When it is in time domain, these three different types of excitations are used. When it is in frequency domain, this excitation is used. What is the name of this excitation? Sine, right? Sine input is used when we are doing discussion of testing of first order system model or any order system model in frequency domain. The excitation used is sinusoidal. If it is in time domain, the excitation used are step input, ramp input, and impulse input. In detail, we will see this in the course. Hope it is clear to everybody.
Yes, sir.
Yes, sir.
Now, because you are telling that you are not aware of frequency domain and time domain, let me take some time to discuss about this. Maybe I will take 5 minutes to discuss about this thing. Remember, this is not a part of discussion of the course. Note, time domain and frequency domain discussion. Okay. In order to give you a picture about this thing, the domains, let me take the example in which we are living. We are living in which world? We are living in this world, time domain. The things which we are able to observe are nothing but time domain. The space in which we are living is nothing but time domain. Okay. In order to understand this more easier, let us see the example of a picture in which time axis, sorry, x-axis is time and y-axis is some amplitude. Okay. I am taking the example of sinusoidal signal. This is called as time domain. What is this we are observing in time domain? The variation of amplitude with respect to time. Is it clear to everybody?
Yes, sir.
Sir.
Yeah.
Yes, sir.
Let us see the corresponding in frequency domain. Are you able to see how many frequencies in this domain? Are you able to see how many frequencies? I am considering it to be pure sine wave. In pure sine wave, there are how many frequencies? There will be only one frequency, right? That is given by 1 by t, right?
Yes, sir.
Only one frequency. When we try to see this picture in frequency domain, where x-axis is frequency and y-axis is corresponding amplitude, then we see only one impulse at one frequency. Suppose that frequency is this one. I am representing this with Fm. This is Tm. So this will be Fm and this will be its corresponding amplitude. In the rest of the cases, it is looking to be 0. This is called as frequency domain. Is it clear to everybody?
Yes, sir.
Yeah. A picture or a world in which we see the thing from the perspective of frequency is called as frequency domain. Right? For us, it is just imagination. In order to see the picture in frequency domain, we need to apply some mathematics. What type of mathematics we need to apply to see the picture in frequency domain? Any idea?
No, sir.
Any idea?
No, sir.
अरे है आप लोगों को आइडिया? थोड़ा दिमाग पे बोझ डालो, you will get the information. This is nothing but FT. FT stand for Fourier transform, right? If we apply Fourier transform, the picture from time domain moves to frequency domain, right? Yes, no?
Yes, sir.
Okay. So I think this much is enough for time domain and frequency domain understanding. Can I move further?
Yes, sir.
Yes, sir.
Yes.
Let us see the content of Unit 2. Unit 2. You see, the title of Unit 2 is Resistive Transducer, right? This is the title of Unit 2. Okay. This is the title of Unit 2, Resistive Transducer. Under this, what we will do is, Before going into Unit 2 discussion, let me make Unit 3. Unit 3 also clear. In Unit 3, what I will do is, we will discuss inductive and capacitive transducers. Okay. Whereas in Unit 4, we discuss about Unit 4 and Unit 5 applications. Applications of transducer. In Unit 4, we will see temperature measurement application in detail. In Unit 5, we will see same application of transducer. Here, we will cover pressure application, right? Or say that. So, make a picture in your mind. Unit 2, we will try to discuss resistive transducer. Unit 3, we try to discuss inductive and capacitive transducer. Unit 4 and Unit 5, we will see applications of transducer. In Unit 4, we cover temperature application, whereas in Unit 5, we will cover pressure application. Hope it is clear to everybody.
Yes, sir.
Okay. I will take one more screen help to make the meaning of inductive transducer, capacitive transducer, and resistive transducer clear to everybody. Before going into this thing, I need to take the help of, that will be a discussion on the course. No problem. Just to explain what is the meaning of inductive transducer, capacitive transducer, and inductive transducer, I'm doing some work on this screen. Let us suppose we have a block representing a sensor, right? The
Yes, sir.
input to this block is nothing but physical world. The input to this block is physical world interaction. Physical world interaction. This sensor is made in order to sense these values and give a corresponding change in the output. Right? Agree or not?
Yes, sir.
Yeah. Usually, if it is electrical based transducer, then we all know that the passive elements of electrical engineering are these three, right? R, L, and C. So what happened? They start giving the information in the corresponding electrical parameter as change in resistance, or as change in inductance, or as change in
Capacity.
capacitance. Agree or not?
Yes, sir.
Yeah.
Yes, sir.
Yeah, the sensor is getting interacted with physical world. If it is belonging to resistive transducer, it give output information in the form of change in resistance. If it is belonging to inductive transducer, it give information in the form of change in inductance. If it is belonging to capacitive transducer, it give information in the form of change in capacitance. And we provide a mechanism to measure these three changes to record the value in the form of their actual unit. What we will do is, we will get these values to pass through a component called as signal processing unit, and the output of this signal processing unit is directly the information available in its actual unit. Actual unit. What do you mean by actual unit? If it is temperature transducer, the actual unit can be degrees C. If it is level transducer, the actual unit can be millimeter. This is temperature. This is level. How about pressure? Of mercury, right? And few other more, right? Okay, and so on and so forth. The meaning of actual unit is the value in their actual representation, like temperature degree C, like level millimeter, or displacement also millimeter, and there are many more, right? And then pressure, of mercury, so on and so forth. Hope it is clear to everybody.
Yes, sir.
Yeah. Remember this thing, most of our transducer are falling in the category of change in resistance or change in inductance or change in capacitance. Let us go back to the discussion of unit 2, resistive transducer. In this case, what we will do is we first try to see the classification of transducer itself. I will show you how to do that classification. This is not the appropriate time to discuss. After that, we will see what is the basic requirement to make a transducer as second thing. Then what we will do is we try to cover the actual resistive transducer examples. The first one is variable resistive transducer, which is nothing but potentiometer. The second one is the strain gauge. And the remaining part of this unit are actually covering the thing related to strain gauge calibration, strain gauge measurement, and their signal processing operation. Hope it is clear to everybody.
Yes, sir.
Yes, sir.
I don't want to give additional information in today's class. I just want to create a picture in your mind about the course content of transducer engineering course. So, as of now, you assume that unit 2 is actually going into resistive transducer. Before that, giving information about classification of transducer and basic requirement to make a transducer. Okay. Then moving to unit 3. Unit 3 discuss inductive transducer with few examples, capacitive transducer with few examples. Like this. You see, the first part of this unit covers capacitive transducer with few examples. Capacitive transducer principle we will see. Then application of capacitive transducer as displacement transducer, hygrometer, and proximity sensor. 3 applications we will cover under capacitive transducer. Then inductive transducer, we will see the principle of inductive transducer. Then later on, we will see 2 applications of inductive transducer. First one is called as linear variable differential transformer. Short form is LVDT. Second one, RVDT, rotatory variable differential transformer. Hope it is clear to everybody.
Yes, sir.
Yes, sir.
This is capacitive transducer principle. Then applications. 3 applications are covered. First one, displacement measurement. Second one, humidity. Hygrometer is nothing but humidity measurement device. That is dew factor. IPL चल रहा ना, dew factor measure करने के लिए we will use hygrometer or humidity touch sensor. Then proximity transducer. For all door automation we will use proximity transducer. Subhan bakery में जाती है आप देखते देखिए, there is one automatic door will get open if we come in close to the contact. और अपना elevator है ना, you see our elevator, if you try to go and stand in front of elevator, it sense you. The sensing is done with the help of proximity sensor, right? And in case of inductive transducer, we cover after principles two transducer, one is LVDT, another one RVDT. Okay, in unit 4 exclusively and unit 5 exclusively we will discuss about applications. In unit 4 temperature measurement application is covered, and in unit 5 pressure measurement application is covered. So I think this much is enough for today's class. If you have any doubt, you can ask. If there is no doubt, then can I take the attendance?
Yes,
Yes,
sir.
sir.
Answer your attendance in order.
Roll number 2, 3, 4, 5. 1.
Roll number?
1, 2, 3, 4, 5, sir. Roll
Roll
number
number
1, 2,
one.
3, 4, 5. 2,
2,
3,
3,
4, 5.
4, 5. Okay, thank you for that. Continue up to 26.
6 present, sir.
Continue up to 30.
Sir, 10.
After 6,
Sir, 7.
7.
Sir, 10.
Roll number 10. Okay. Continue, please.
Roll number
Sorry.
13. 1 3. Roll number 13.
Roll number?
13. 1 3.
Okay, 1, 3, 13. Continue.
14 present, sir.
14. Continue, please. Okay, up to 30.
17. 29.
17.
22, sir.
After
29.
17. Sorry.
22.
29.
29.
22 also, sir.
Okay.
22.
Please loudly.
22, sir.
Roll number 2.
22.
Okay, 22.